Okay, so in 4.1 and 4.2, we were learning about how to write the equation of a line if we have 2 points, or if we have the slope and the y-intercept, right, or a point in the slope. And today we're going to talk about parallel and perpendicular lines. So parallel lines are two lines in the same plane that never intersect. They never ever touch. So two distinct non-vertical lines are parallel if they have the same slope. So vertical lines would be parallel, right, because they're straight up and down, or flat horizontal lines would be parallel. So they have the same slopes. Like if I think about this line, this slope would be down 1, 1, 2, 3, 4, over 5. Down 1, 1, 2, 3, 4. Did I count wrong? 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, we're supposed to be deciding which ones are parallel. I'm not even paying attention to the directions. Anyways, I can count the slope, right, by going down 1 and to the right 5. If I do this one, it's down 1 and to the right 4. This one is down 1 and to the right 1, 2, 3, 4, 5, correct? So not all three of these have the same slope because this one is negative 1 over 5. This one is down 1, right 4. And this slope is down 1 and right 5. So which ones would be parallel? Line A and line C, right? So A and C. What if I didn't have the graphs? What if they just gave me the points? How would I be able to tell if the lines were parallel? What would I have to find? The slope, right? Because I'm looking at the slope. Two lines are parallel if their slopes are the same. Okay? And apparently I have two number ones, but that's okay. All right. Write the equation of the line with the given information. All right? So they're telling me that I'm passing through this point. So I have a point. What do you need every single time you write the equation of a line? What do you always need? No matter if you have anything else. You always need the slope, right? So I have a point that I'm going through, but I need a slope of this line that I'm going through. So the only other information that we have is that we are parallel to this line, right? And remember, when you're in that form, y equals mx plus b, see how I have y equals a number times x plus a number? The slope is always the number that's in front of the x, right? So if I'm parallel to this line, and this line has a slope of 2, then that means my slope is also 2. So let me reiterate that. I'm going through this point, okay? I have a line that's going to go through this point, and it's going to be parallel to this line. I already know the point I'm going through, right? But I need to know my slope, and they told me that I'm parallel to this line, which means my slope is going to be the same. All right? Now I have my information, and I can write my equation. If I have the point and the slope, what form am I going to use? Point-slope form. So I've got y minus, and then I'm going to plug in my y value, which is negative 4, equals my slope times, and then I'm going to do x minus this x value, so x minus 5. And then I'm going to simplify these double negatives, so that gives me y plus 4 equals 2 times x minus 5. Now, I want you to put that in slope-intercept form every single time, okay? So I'm going to go ahead and distribute my 2, just like we did in yesterday's lesson. So 2 times x is 2x, and 2 times negative 5 is negative 10. And then the last thing I have to do is move this 4 over. So I'm going to subtract 4 and put that with its like term on the other side. So I end up with y equals 2x minus 14, and that's the answer I want. All right? So same thing goes for this one. I already know the point I'm going through, but I don't know what the slope of this line is. So I'm going to look at the information that they gave me. They said I am parallel to this line. So that means that my slope is going to be the same, and it's that number in front of the x. So my slope is 1/4. So that statement right there, you're just pulling information, okay? And get used to doing that, because in geometry you got to pull information a lot. They give you stuff and you have to use things. So I'm going to use the point slope form, because that's what I have, to write this equation. So I have y minus my y value of my point right here, so 2, equals my slope, 1/4, times x minus -4. And then I'm going to change that double negative to a positive. But then I want you to put it in slope-intercept form for your final answer. So you're going to go ahead and distribute that 1/4. So remember, same process every time. You're going to distribute and then move the number. So 1/4 times x is 1/4 x, and 1/4 times 4 is 1. And then the last thing I do is I'm going to move that -2. So I add 2, and you're going to put that with the 1 because those are like terms. And that gives me y equals 1/4 x plus 3. All right, so again, I'm going through the point 3, 1, so I know that's information that I need. And I am parallel to this line, which means I will have the same slope. So my slope of this line that I'm going to write the equation of is 3. And since I have the point and slope, I will use point slope form. So y minus my y value of my point, which is 1, equals my slope times x minus the x value of my point here. All right, I have nothing to simplify, right, as far as point slope form. I don't have any double negatives. So I'm going to go ahead and distribute my 3. So keep your y minus 1. 3 times x is 3x, and 3 times -3 is -9. And then the last thing I do is move that -1 by adding it. So y is equal to 3x minus 8. Okay, last parallel one, I believe. So I'm going to use the point that I'm going through. And then I'm going to look at this statement. I'm parallel. So that means my slope will match. Slope is always the one in front of the x. So my slope is 2. All right. So point slope form. Y minus my y value, which is 3, is equal to my slope times x minus my x value of -1. So I'm going to fix that double negative. Make it a positive. And then I'm going to go through the process to solve for y again. So I'm going to distribute the 2. 2 times x is 2x. And 2 times 1 is 2. Then move the 3. So I add 3. So y is equal to 2x plus 5. And in the end, remember, if you're parallel, that number in front of your x should be the same, right? So if you have a different number here, then you've done something wrong. All right, perpendicular lines are lines that intersect and form a right angle. How many degrees is a right angle? 90 degrees, right? So two lines that make a 90-degree angle are perpendicular lines. So like non-vertical lines are perpendicular if and only if, by the way, the abbreviation for if and only if is IFF, just so you know. I will use that in the future. If and only if their slopes are negative reciprocals. So if you have like a vertical line and a horizontal line, those would be perpendicular. By the way, a negative reciprocal, for example, would be, let's say I said 3/4. I also, instead of negative, I like to say opposite. So that's the word, that's the verbiage I'm going to use is opposite. I guess that's not a verb. Verbiage. It's the word I'm going to use. Opposite reciprocals. So what that means is if I'm perpendicular, then if this is positive, then a line perpendicular would be a negative slope. And then you would flip the 3/4 to 4/3. So opposite sign and a reciprocal. So we'll call that opposite reciprocals. So we're going to determine which of these lines, if any, are parallel or perpendicular. If you want to know if something is parallel or perpendicular, you need to be able to identify the slope, right? So if you look at this one, y is already solved for, but if you look at this one, it is not. So we need to get y by itself. So I'm going to go ahead and subtract x to move it over here on the other side. So I have 4y is equal to, and then you're going to put that x in front of the 3, right? We always like the x to be in the front. And then you're going to go through and divide everything by 4. So each term gets divided by 4. So I have y equals, now remember I don't like to keep the x on top of this fraction. That's a 1 right there. So this would be negative 1 over 4 times x, and then plus 3/4. And then same thing with this one. We need to solve for y. So I'm going to go ahead and add the 2x. And I want the x to be in front of the number that doesn't have the variable. So negative 8y is equal to 2x plus 16. And then we'll go ahead and divide by the negative 8 every term. So y is equal to 2 over negative 8 reduces. And remember, if you're not good at reducing, you can literally just plug in that fraction in your calculator, and it tells you that it is negative 1/4 times x, and then 16 divided by negative 8 is negative 2. All right, so remember, we're identifying which ones are parallel and which ones are perpendicular. So let's start with parallel. Parallel lines have the same slope, right? So tell me, what's your slope on part A? Slope is 4, right? Just that number in front of the x. What's the slope on part B? Negative 1/4, right? And then the slope on part C, in front of the x you have negative 1/4. So slopes that are the same, those lines are parallel. So what's parallel? B and C. So B and C. Is there any other two lines that are parallel? No. All right, perpendicular. Those are opposite signs and they are flipped. So if you think about the slope of this one, this is really 4 over 1, right? If you have an integer here. So if I flipped that, that would be 1 over 4, right? So this is positive. So for something to be perpendicular to it, it would have to be negative 1 over 4. That's both of these, right? So A and B are perpendicular, and so are A and C. Okay, now we're going to write an equation of the line with the given information. All right, they told us we're passing through this point. So I'm going to write that point down because I know I need the point. And then they said we are perpendicular to this. So tell me, what is the slope of this line? It's 1/2, right? This line right here. But if I flip this and change the sign, if you flip it, it's 2/1. Do I need the 1? No. And then you have to change the sign. This is positive, so this is negative. So the slope of our line that we're writing the equation for is -2. So if you see the word parallel, you just use what's there, right? If you see the word perpendicular, you need to change the sign and flip it. All right? Then we do the same exact thing that we did in the previous problems. So I have y minus my y value is equal to my slope times x. Now I'm going to do something a little different here because we've been keeping the double negatives, right, and then changing them. And if that's what you need to do, then keep doing that because it's just an extra step. But if you already know that this is negative, it's always going to change to a positive, right? So I'm going to go ahead and put +3 here. It's kind of like the signs are going to be the opposite of what they are in the point. Is everyone with me on this? Now all I have to do is distribute and move the 1. So I've got y minus 1 equals distribute. -2 times x is -2x. And -2 times 3 is -6. And then I'll add the 1 and put that with the -6. So y is equal to -2x minus 5. All right, so on number 7, we're passing through the point for -3, so that's valid information. And I'm perpendicular to this line. So the slope of the line they gave me is 4. And I'm going to make that a fraction by putting it over 1. So the slope of the line that's perpendicular to that, we would have to flip it. And since it's positive, now it is negative. So the slope of our line we're writing the equation of would be -1/4. And now we're going to do the same process that we just did. So we have y, and then the y value is negative, so that means this is going to end up being a +3 equals, plug in your slope, times x minus 4. And now we go ahead and distribute and move the 3. So we have y plus 3 is equal to -1/4 times x is -1/4 x. -1/4 times -4 is +1. And then go ahead and subtract your 3, put it with that 1 back there. So y is equal to -1/4 x minus 2. All right, let's do one more of those. So we've got the point we're going through, and we're going to pay attention to the word. We are perpendicular to this line right here. So I'm going to take its slope, which in this case is -3. I'm going to make it a fraction. So I'm going to put it over 1. Remember, if it's already a fraction, then you just flip the numbers, right? If it's 3/4, it would be 4/3. So it's negative, which means the slope of my line is going to be positive, and then I'm going to flip and do 1/3. And use my point slope form. So y minus 5 is equal to 1/3 times x. And then I know I'm going to have that double negative, so I'm going to change it to a +3. And then I'm going to distribute and move the 5. So y minus 5 is equal to 1/3 times x and 1/3 times 3, which is 1. Add the 5. So y is equal to 1/3 x plus 6. right, the position of a helicopter search and rescue is shown in this graph right here. I drew this helicopter by hand, as you can see. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. So in other words, if my helicopter is flying, here's the shore, right? This would make a 90-degree angle, correct? So it says write an equation that represents the path. What's the only thing you really have right now that's just blatantly given to you that you know you need? This point right here. So I'm going to write that down because I know that I need the point. What else do I need? I need the slope. So it would be easier for me to just count on the line, right? I want the slope. Now here's the thing. I can find the slope of this line and I can find the slope of this line. I think that this is a really awful problem for whoever put this in this thing. This is from your book, and so that's why I chose this one. If I find the equation of this line, then I don't have to change anything, right? Because that's the path I'm finding the equation of. If I found the slope of this line, I would have to flip it and do the opposite, right? So I'm going to show you what I mean. Let's say that I find the equation of, or the slope of this line right here. I've got to find a spot where it crosses evenly, right here, right? So if I count, that would be up 1, 2, 3. So the slope would be 3 over 2. If I find the slope of this line, let's see, crosses evenly here and here. This would be down 2, so that's negative 2, right? And over 3. Do you see how they're flipped and they're opposite signs? That means that they're perpendicular. So if I use this one, that's the line I actually want the equation of, right? So I don't really need to flip anything. If I chose the slope of this line, then I would need to flip it. So it's just kind of a pointless problem for that. So I'm not going to go through the whole process because we've been doing that for 8 problems on this one and some in the last one. So I think we're good. I just wanted to make sure we explained that and put some thought into it. Okay.